These webinars are organized by Cristiana Barandoni, who is also managing the whole meeting together with Ivana Cerato, and are dedicated to the subject of color change in sensitive heritage collections and to the use of advanced and innovative research methodologies for their study. These perceived webinars started quite a while ago in April this year and are scheduled until basically Christmas of this year. And their objective is to enhance the digital capabilities of scientists and cultural institutions through a service-oriented AI architecture and toolkit, while also developing a new design theory for both on-site and remote virtual reality, augmented reality, mixed reality, all the realities that you can imagine experiences. Studying these fragile objects in our collections is a very complex endeavor, and reconstructing their original appearance while effectively communicating the results to others requires great attention. Perceive emphasizes the integration of advanced technologies on one side to enhance the understanding and management of the types of objects in museum collections that we chose for these subjects and for this project. And these include classical statues, paintings, works on paper, textiles, autochrome and analog photography, and digital art. All webinar episodes are organized with two speakers who will address the same topic from two different perspectives, followed by a Q&A question. We really value your participation and feedback, and we would greatly appreciate it if you could ask questions in the chat and to enrich the discussion. And then at the end of the presentation, if there is any time, the speakers will be happy to answer the posted questions. Today, we are focusing on scenario 3, fading textiles, specifically objects from the Victorian Albert Museum, where I am today. And our speakers will show how they use digital techniques to realistically show how the colors of two textile objects have faded over time, while also reconstructing their original appearance, helping us to better understand and preserve them. Now, a few words about the two speakers. They are Saptarshi Neil Sinha, a research associate at the Fraunhofer Institute for Computer Graphics Research in Darmstadt in Germany. He holds a master's degree in computer science from the University of Saarland, where he completed his thesis in the field of computer graphics in collaboration with DFKI and the Max Planck Institute for Computer Science. After that, Neil worked in the industry, developing applications in the field of real-time rendering on the web. And since 2021, he's been part of the virtual and augmented reality department at Fraunhofer IGD, focusing on projects related to the automotive industry, cultural heritage, and bioeconomy. His research interests include scene digitization, analysis, and editing, utilizing learning-based approaches, synthetic data generation, and real-time rendering, leveraging spatial data structures for streaming a large 3D model. The second speaker is Irina Mihaela Ciortan, is a postdoctoral researcher at the Color Lab and TNU, where she previously completed a PhD degree in computer science with a thesis entitled Spectral and Multi-Light Imaging for Cultural Heritage, Material Analysis and Appearance Reconstruction. Irina holds a joint MSc diploma in Spectral Science and Multimedial Technologies, awarded by the Four-University Erasmus Mundus Consortium Color in Informatics and Media Technology, and a BSc in Computer Science issued by the Faculty of Cybernetics, Statistics and Informatics in Bucharest, Romania. Currently, she works in the Horizon EU project Perceive, capturing and analyzing visual data towards designing computational methods for the digital simulation of color changes in various artworks, including paintings, textiles, historical photographs. With today's episode, I'm nearly done. We are well into our second cycle of Perceive webinars. If you want to stay up to date with the remaining ones, please visit our social channels, LinkedIn, Facebook, YouTube, X, Instagram, and so on. And of course, our main website. And you will find the links in the chat during the course of this presentation, this webinar. And finally, I wish to remind you that this webinar is recorded and that this video will be available on the YouTube channel of the Perceive project soon. So thank you for participating today. We hope to see many of you at the upcoming events. And now let's welcome Neil and Irina. Over to you guys.
Thanks, Lucia, for the introduction. So welcome everyone to our webinar titled SimTex, which is virtual 3D restoration and simulation of fading in fugitive textiles. So today, my colleague Irina and I will present 2 use cases where fugitive textiles exhibit color loss in the light-sensitive regions. We will discuss how we extracted this semantic information in the 3D models using image-based approaches and visualize potential restoration and fading simulation in these areas. So first, you see here a video of a SimTex tool, which we developed as a part of the Perceive project, focusing on the textile scenario involving fugitive textile. So basically, this tool allows us to showcase potential colors of the fugitive regions, illustrating how they looked in the past and how they could have looked in the future. Here is one scenario demonstrating the video of this kimono. This is a 20th century kimono housed at the Victorian Albert Museum, where the green regions are faded and we see different simulations. But this video just serves as a preview of what's to come. We will present the details of the tools, features of the tools in the course of the presentation, and a live demonstration will also be presented at the end of the webinar. So coming to motivation, why we want to do this? The reason is like fugitive dyes and textiles experience fading over time due to various factors, and there is a need for virtual restoration of these areas that contain these dyes to preserve cultural heritage. So in this presentation, we will focus on 2 use cases, both housed at the Victorian Albert Museum, a 20th century kimono, where you see the green regions have faded. It's composed of miscanthus and indigo is quite light sensitive. That is the reason why we see different shades of green over here. And on the right, you have the Victorian dress, where the arrow points to the turquoise, which has lost most of its color. For those interested in gaining deeper insights into the scientific analysis of these faded dyes, I encourage you to refer to the previous webinar conducted by Brenda and Katarina. This session covers essential findings related to the research of fugitive dyes in these textiles. In this presentation, our main objective is to virtually simulate various colorization of these 2 textiles, but also in 3D. So why in 3D? In 3D because it helps us to better understand those colors in terms of visual analysis and reasoning, because we can see different camera position and light direction, and this gives us a more accurate representation of the color based on the materiality of those dyes. Since we want to do it in 3D, the first step in this process will be to digitize the data in 3D. So in the left, you see the 2 3D models of those textiles, the Victorian dress and the kimono, which was digitized using photogrammetry in the Victoria Albert Museum. And in the right, you see the corresponding like texture atlases. Just one moment, maybe I find my pointer here. But doesn't matter. So you can see those small images in the right. These are like packed into a single image, which is the segmentation atlas. This is the texture atlas. And each of these small images have a coordinate, which is called the UV coordinate. So if you can imagine the U to be the X coordinate and V to be the Y coordinate. And each of these coordinate maps to a specific point in the surface of the 3D model, which is the dress or the kimono. So we can use this information to find out the fugitive regions in the textiles. That's the reason why I explain why we need this texture atlas. Now, once we have the 3D digitized model, we need to segment the light-sensitive regions. And how we do it is using the image-based approaches. The reason is doing a segmentation in 3D is quite tedious manually, and also it's a complicated process. But in 2D, it's quite advanced in terms of segmentation compared to 3D. So what we here do is the texture atlases have this fugitive colors of the fugitive dyes. And then we use color-based segmentation, namely HHV segmentation of the faded regions with different thresholds, and it works really nice for the kimono. And you can see in the figure in the right, the green regions has been segmented quite nicely. And this red colors represent the mask of the corresponding regions. We tried the same approach for the Victorian dress doing the HSV color segmentation. The results were plausible, but they did not achieve the same level of fidelity as those for the kimono. The reason is because the fading was too intense, and the reason then that the variation in colors between the different regions were not that much. But the results were plausible, as I said. During the course of the project, we also found out that not only the turquoise, but another dye faded in the Victorian dress. And namely, this is the purple, which you can find nicely shown in the hyperspectral image in the left. This image is contrast enhanced, so one can see it quite nicely in the left. But the HSV segmentation failed. The reason is there is very less variation in colors. Also, the purple region has very fine-grained features in them, like these Y structures. And when we do that, it's all getting overlapped. And so it doesn't work. So we saw that color-based segmentation didn't work for the Victorian dress. And there are challenges associated with it. So we chose a segmentation based on structural features and homography for more accurate segmentation of the faded regions. How we did it? We took the original atlas, then we cropped a region where we had both the features, like the features of the faded purple and also the faded turquoise. Once we had those two features, we segmented to create two regions of interest, the two masks. And then we marked 11 different unique features in these crop regions. And the target images are those small images in this original atlas, UV maps. And then we also marked similarly the 11 control points similar to the source image using a web application. Once we could do that, then we found the correspondence between those two features to compute the homography and then transfer the mask from the source image to the target image. Mathematically speaking, homography leads to a matrix which one can use to warp the target image to the source image. And then since we have the mask in the source image, we can transfer it to the target image. So we had a mask of the small regions based on structures. And then we stitched to get the final atlas. So here you see an example of the segmentation of the faded turquoise based on structural features for the Victorian dress. But the limitation is that we have the segmentation only in the partial areas. And the advantage is that segmentation is very, very accurate, but it's only working in the partial regions. So consequently, we face a trade-off. We can achieve a complete atlas with less accuracy based on color-based approach, or a more accurate segmentation that doesn't fully cover the atlas. To address this, finally, we combine those two approaches to get a plausible segmentation, which we will discuss later in the presentation. As you can see in the left, you can see the two different segmentation masks for the purple and also the turquoise. The red regions represent the turquoise and the blue regions represent the purple. And when you render it, this is how it looks in the partial regions. I would say this is quite nice, since using color-based segmentation, we couldn't get these fine-grained structures at all, but we now can at least partially show the violet or the purple in these regions where the blue regions is segmented. So this makes us come to the end of the segmentation process. So we have now semantic information of those fugitive dyes. We now concentrate on the potential virtual restorations in the spatial dimension, which is 3D in our case. From now, we will only focus on color restoration simulations. To do like color restoration simulation, we have chose 3 types of reference data. One is mockups, which are like small patches of textiles having the same chemical composition as the dyes present in the original textile. We have aged and unaged versions of those mockups. Next is hyperspectral data, which shows the composition of the different elements present in this textile, which we use along with fading data to simulate the fading over time. And finally, we have photographic documentation. So we have pictures of the kimono at 2006 and 2019, so at various timestamps how the kimono looked. And also, interestingly, we have the picture of the inner surface of the kimono, which faded less compared to the outer surface, which can be interesting to see how the color could be, because the inner and outer surface should have similar colors. We also have data of various aging instances of the mockups for both kimono and Victorian dress. The mockups have been subject to different levels of aging using light exposure, allowing us to see how the colors change over time. This information has been used by us for simulating the fading and will be explained in detail in the course of the presentation. Now, coming to visualization of simulation modes, we have 3 different simulation modes here. The mockup appearance, which is solely based on the mockups, the aged and the unaged mockups, where we capture the materiality of the mockups and apply in the fugitive regions. Spectral unmixing, where we simulate the fading over time. And photographic documentation, showing color restoration based on reference images. Now, to sum it up all in a nutshell, this is what we do. We have a 3D model and the corresponding atlas. Then we segment the atlas in the fugitive regions using different image-based approaches, and we get the segmentation atlas. This information then can be used to apply the different colors. So the mockups were captured by appearance capture device, namely the TAC7, where we get the material maps, and this can be then applied to the 3D model. And the fading data can similarly use for simulating the fading, and the reference data for applying colors in the different periods of time or based on the reference like the inner surface of the kimono. Now coming to the first part, which is mockup appearance. How do we capture the material appearance of the mockups? We use the device from X-Rite, which was done in collaboration with University of Bonn, which is called the total appearance capture, or TAC7. Why do we use it? Because it's very good in capturing material properties of fabrics. As you can see here, we have 3 different fabrics, like the lycra, the satin, and the brocade. And the anisotropy of these materials has also been captured quite nicely. So the digital material assets captured and processed by this device is quite state of the art. And here is the entire process, how it is done. So you have this device, then you put this in the tray, all mockups, we insert it, then it takes around an hour. So we have kind of a setup where there are multi-light and multi-camera, taking pictures on different spectra of light and also from different view direction to have the entire multispectral appearance. Once we have this data, it's quite large, and we need a fitting model, which was done using a software from also X-Rite. It's called Pentora, getting the material maps. And in computer graphics, we can use these material maps in some parametric models called shading models to get the actual material appearance of the 3D models from different directions. Here you can see the simulation of the kimono using the mockups. So here is the unfaded, the intermediate, and faded. So the intermediate, we used the unaged mockup, and for the faded, we used the aged mockup. And the unfaded was kind of the unfaded mockup in using a low exposure. This color was done after consultation with the conservational scientists. So because this unfaded color seemed more plausible when we saw the data of the scientific analysis. And finally, we have the simulation based on mockups of the Victorian dress, which is unfaded and faded. And you can see here the dress is visibly prominent, the green in the unfaded part, and in the faded part is completely lost. So you can see the direction from different camera views, how it looks. Now we have this segmentation based on structural features, which we already explained in the previous slide. So we had segmented the atlas partially in the partial areas, and when we apply the segments, this is how it looks. So you can see how the faded and unfaded mockups, when applied to those partial areas, along with the purple looks. Another thing I want to mention is the purple is like a representative color, which was given to us by a conservational scientist, and the analysis is still ongoing process. So once we have the data, we can do all those captures and apply them accordingly. Now coming to the final segmentation process, which we did is like we took the partial segmentation of the turquoise and then combined it with the color-based segmentation of the turquoise. And you can then see the turquoise in the whole dress and the purple on the partial areas. And this is how it looks when we apply the mockups there. And this brings me to the end of my part. Now, Irina will continue the presentation. She will describe the two modes, the spectral unmixing and photographic documentation. And finally, she will also give a live demo of our tool and how it works. Over to you, Irina.
Yeah, thank you, Neil, for building a strong foundation for the work and for my part. I will share the screen now. Okay. Okay, should go in full screen. Okay, so you already saw the simulation based on mockups. And this was done with straightforward appearance transfer from the total appearance capture. However, you might have noticed that perhaps the colors are too vivid or too saturated, or let's say a bit disruptive with the rest of the textiles or with the other colors in the textiles. That's why we were looking for a more natural look, and we are thinking that we should establish a connection between the mockups and the current state of the two textiles. Obviously, the mockups are trying to imitate as much as possible the composition of the textiles, but this is an ideal case, so there will always be some differences. Moreover, the mockups are fresh, and also the artificial aging experiment we did was not, or it has a limited time span, so it's difficult to correlate with the actual time span of the aging of the textiles that are displayed in the museum. So to establish this correlation between the appearance of the mockups and the current state of the two textiles, we apply a technique called spectral unmixing that helps us find the distribution of each dye in the artworks, in the textiles, and also the concentration. So this is done based on hyperspectral imaging, which was also done in this project. We captured only 2 details from each textile with hyperspectral imaging. That's because it's very time consuming to scan all the textiles. But a detail is enough because that helps us find the distribution of each of the materials. So in spectral unmixing, we need the reflectance, so the spectral signature of each of the pure dyes, so each of the components in the textiles. And in this case, we have the turquoise, which is a point of interest in our project because we know it fades the most and it's what we want to simulate in past and future. But then we also have other dyes, as you can see. So we have some red features here, some orange, also the purple we talked about. And we also have some shadows that happen because the textile is not flat. So hyperspectral imaging is a technique typically used for flat objects. It can be used for three-dimensional objects, but then we have these shadows. So we can also segment them to remove them from the other materials. So we took these spectral signatures from the hyperspectral imaging because in a hyperspectral image, each pixel is characterized by its spectral reflectance. So for red, orange, and purple, we actually took the signatures from the image itself. So we sampled some pixels from the corresponding categories, and we got these spectral signatures. Then we have the mockup. So the spectral signature of the mockup, of this mockup. And if we use this one to unmix, we can find out how much of the fresh mockup is found in the textile. So this helps us to simulate from now the current state of the textile in the future. Because once the concentration map are known, so we know how much of this mockup is still left in the textile. We also have the aging data. So we monitored spectrally the aging, and we have different spectral curves of the same mockup. So once we have these distribution maps and the different aging steps of the mockup, we can recombine this spectra with these distribution maps to get a fading prediction in the future. So this will help us to see how from today the textile will age in the future. And here you can see the remixed images for several times. So this is the last time step that we measured. And if you focus on this side, so this is again the simulation of the hyperspectral detail. And you can notice here the fading. So here it looks a lot more turquoise, and here it starts to disappear. And finally here we can almost no longer see that it's turquoise. But then we know that this turquoise is a pure dye, so it's only based on this green dye. It's not mixed as in the case of the kimono, where the green is a mixture of 2 dyes, miscanthus and indigo. So in this case, we actually took the spectral signature from the turquoise from the hyperspectral image from an area, and you can see here the differences between the turquoise in the hyperspectral image, so in the textile, and the spectral signature of the mockup. So you can see there are quite some differences, and because the curve of the turquoise in the textile is a bit higher, you can see that obviously it's already more faded than the fresh mockup. So in this case, because it's a pure dye, we can actually attempt restoration by using the signature of the current state turquoise to unmix the hyperspectral image. And indeed, we get a higher abundance map because we unmix with something that is lower, so we get a higher abundance. And with this abundance map, if we replace in the remixing part with the signature of the fresh mockup, we can attempt the restoration of the turquoise. So you can see here in the left part that because now the abundance map is higher, we get a stronger turquoise than we had in the previous parts. Finally, for our app, we need only texture images. So Neil already said that in the case of the mockups, we get these texture images from the total appearance capture. In this case, we are dealing with a hyperspectral image where we did this correlation between the mockups and the current state of the garments. So we need this texture image. So in this case, we only take a subsample of this hyperspectral image to be able to infill in the app. So these are the texture images at the various time steps. So it goes like zigzag. So you can see the current degradation. So this would be the restoration in the past, then the current state, and then the future degradation. And here you can see the video where we slowly slide through the different moments in time from past to future. And I hope you can see, especially if you compare with the results of Neil, that now the colors are a bit toned down and they are more in sync with the rest of the colors in the dress. So they're not as disruptive as it was with the case of the mockups. Then we did the same for the kimono, or almost the same. So in the case of the kimono, the green, as I specified before, is a mixture of two dyes. It's not a pure dye. So we have indigo and miscanthus, and Neil in his simulation used we have also a mock-up of the mixture of the two. So Neil used the mixed mock-up. But in my case, because I'm performing spectral unmixing, I use the mock-ups of the individual dyes. So here we have the spectral signature of the two dyes in the mockup. And then again, the kimono has other dyes that were not included in the mockups because we didn't consider them sensitive enough to be included for the artificial aging experiment. So for these other dyes, we again sampled their spectral reflectance from the hyperspectral image itself. And then we did the same. So we have these pure dyes, the ascend members. We applied spectral unmixing in this image. And then the intention is to, once you get the abundance maps, the concentration maps, is to remix them with the different aging steps for each of the two single dyes. And here you can see the distribution of the various materials in the kimono. So we have silk, which is here. So it's the substrate of the fabric of the kimono. And in some areas it's left uncovered. So that's why you can see here where it's red, it's like strong signal of silk. And then we have the miscanthus, which is a layer beneath this part everywhere. And then here we have the parts where indigo is still remaining. In some areas it has faded quite significantly, but here we can see that it's still strongly remaining. And then we have the other dyes, so the brown dyes, this lives here, and then a small part of this blue dye, of this element here. So we have the concentration maps, and then we can again do the remixing with the aging of all the dyes. And so for the materials that were aged, so indigo and miscanthus, we used the aged and the aged spectra, and then for the rest we just kept the initial spectra. So for the brown dye and the blue dye, we didn't change anything in the remixing, so they are supposed to stay the same. So then we do the remixing for all the time steps, and again you can see here how the appearance changes. And as you remember, in the Victorian dress, we tried to attempt both restoration and fading in the future. And this was possible due to the fact that the dye, the turquoise dye, was a pure dye. But in this case, because we have a mixed dye between indigo and miscanthus, we cannot attempt the restoration part, because then we would need to unmix with the current state of the dye, but then this is already mixed, so it's not single. So then to get the, let's say, to attempt the restoration, we actually sampled two areas in this detail. One where we still have a lot of indigo, and the green is in, let's say, good conditions, and another one where it's already significantly faded. So in a way, we consider this is a restoration of the past, and then this is fading in the future. So we sample texture images from these areas, and we put them, we concatenated them to get the a continuous fading simulation of the textiles. So you can see how the appearance of the green changes from strong dark green to very or lighter green with almost no blue component. And again, here you can see the video that shows the continuous simulation. And if you remember from what Neil showed, and also we'll see in the demo, again, the simulation with the mockups, especially for the kimono, was very bright. It was jumping to the eyes, but in this case, we have a more natural look. Okay, so this was spectral unmixing, and we are done with it. Lastly, our third source of data was based on photographic documentation. So we found from the Museum Digital Gallery two pictures of two details in the kimono, one taken in 2006 and another one taken in 2019. So we took an area of the green to get the texture to infill in the simulation from both details. And you can already see from the details that the fading is visible. So here we have a stronger green, darker, and here it's lighter. And again, it seems that the blue has a bit faded. Lastly, we also have a photo from the inner side of the kimono. And we also use that one to simulate. So then we can have various simulations of the restoration based on different types of evidence. And here you can see the simulations with the different pictures. So 2006, 2019, and the inner surface for the full surface of the kimono. We did this only for the kimono because we didn't have such pictures available for the Victorian dress. Lastly, in our visualization app that you'll see in just a few minutes, we can play with the color temperature of the visualization. So if we'd rather see all these simulations in a colder or warmer color temperature, we can do that. For both objects, and we can also change, so we can decrease or increase the intensity of the light if you want brighter or darker images. So in conclusion, we did all this work that we then outsourced in a tool. And the purpose of this tool or app is to help specialists, experts, curators, conservation scientists, conservators to visualize all the types of potential simulations of the two textiles that has different sources of input data. So then, and also different methods, and then they can decide which one is the most plausible. In this tool, we utilized a 2D parametrization of the 3D models, and this can be further improved with learning-based approaches. Then, as future deployments, these fugitive areas could be tracked in an AR application to show the simulation as an overlay to the actual textiles, for example, even on-site in the museum. And then also we are looking to improve the segmentation and appearance modeling using this fabric or yarn-based segmentation approaches. And this is something that we would like to follow up, especially if we want to model the color change of the purple dye, which is now only work in progress because it's something we figured out during the work. And then we have the demo of this this visualization app. But also you can take now a screenshot because we published this work in a recent Digital Heritage Conference in September, and this is our publication. So if you want more elaborate details on the work, you could go and read this paper. And now I will switch to the demo. Please let me know if something goes wrong and you don't see what I'm saying that you should see. So here we have the 3D model of the kimono, and this is the 3D model as we received it, let's say. And it's 3D, so you can rotate it, you can see the backside, you can zoom in and zoom out, and again rotate. And then with this model, you can see the segments. So where we segment the green dye in all the surface of the 3D model. So with this, we are actually performing spatial restoration because you can see in the present or in the current state that in some areas, the green is already very faded, especially in these very thin lines. So it has a different appearance than, for example, the main core of the kimono here. So with this segmentation, we are performing a spatial restoration, so you can see where this green was in the full surface of the kimono, and then you can simulate it in a similar way without making the difference between which parts are less faded or more faded. So once we did the segmentation, then we have the three modes of fading simulation. So we have the mockup appearance. And here we have the restoration, then intermediate state of fading. So you can see a very, very bright, strong grass-like green. And then we have the faded appearance that was done again with a direct appearance transfer of the mockup. Then we have the spectral unmixing. And here we don't have any super strong vivid green as we had before. Again, the colors tend to look more natural and more in sync with the patina of the kimono. Lastly, we have the photographic documentation, so the photo from 2006, and then 2019, and the inner side photo. And as I said, it is possible to increase the intensity, so you can have brighter images. So you can change this and then go again to the fading simulation and see it in a brighter intensity. And then also you can change the color temperature. So if you want to see it in a warmer light, incandescent like light, or daylight, let's say temperature. Okay, so this is our demo. Again, the purpose of this demo is to help experts visualize all the possible scenarios, because in the end, we don't have a full ground truth. Whatever we do here are speculations, but there are informed speculations and based on different scientific approaches. So then experts can decide which one is more plausible. That was it. Thank you.
Thank you. Thank you very much, Irina and Neil. Well, so many results. It's very hard to believe that, you know, you did all this in just over 2 years because it's so much data and so much work that went into the whole project. I don't know if anyone has got, there is one question in the chat. I've got one or two of my own. I don't know if there is anyone else from the audience who would like to ask any additional questions. If you do, please put them in the chat. The one that is already in the chat reads, what future potential does AI have in automating the segmentation and appearance transfer processes? And how might this increase efficiency and reduce the risk of human error in the conservation of fragile textiles? It's a lot of stuff in one question. So
Yeah.
I don't know if you probably can see it in the chat. So you may want to answer part of it in time.
Yeah. So in terms of 3D, I mean, to segment everything automatically with AI today is still an unsolved problem because they have different meshes. And in terms of cultural heritage, it's also very difficult because the criteria for segmentation is often not known because they find new data and say, okay, this is there. So idea will be to have some kind of a user guidance, like you have multi-view images, and few of the images, the people can say, okay, I use the AI tools to segment the coarse region, or for example, the entire parts of the dress, and then use a smaller tool to just go to the fine regions, what we need. And this kind of approaches, I think, is the future till we get a, I don't know, which is like utopic to have a model that just throws in and gives you a segmentation, which people think it's not possible. So this kind of approaches can help to refine the segmentation to the areas of interest. And it will be all more authentic in the sense like the person doing the analysis also fine-tunes it in a shorter time frame. And such an approach we already use for the polychromy use case for the statue, and people can have a look at our tool there, how we do it. And regarding the appearance transfer process, I think the AI-based approaches are very good in uncontrolled environment. For example, if you have an uncontrolled setup in the wild, like if you go with a camera and in the outside, and it still beats the classical approaches like gonareflectometers or like laser scanners. The reason behind it is like these devices do not work well in the wild. But when it comes to control setups, AI-based approaches are still far behind the control setup environments like the total appearance capture, because it has really the understanding of the light, camera, where it comes from, the entire BTF, which is the bidirectional texture function. So we have different camera position, different light direction, and you have the entire data. But this data is also like you cannot use it, and there are like fitting models to fit it to approximation models, which is like can be loaded in any device and is pretty good. So I would say AI-based models can give you plausible results at the moment, but not high quality results. But in terms of if you have like not possible to have such a device for a huge statue, for example, we can do that. In their AI-based methods will be better because it's in the wild. And
thank you very much.
Yeah.
I don't know whether Irina wanted to add anything, or I can ask my next question.
I think Neil gave a thorough answer.
The question is a more general one. The next one, from your perspective, coming from slightly different worlds, you know, that you're not necessarily embedded in collections and in museums and dealing with objects on a daily basis, what were the key or most valuable lessons that you learned from your current approach? What is the takeaway for you, you know, professionally, but also in general, if you have to put it out there to people like me who work in collections? What is the most crucial lesson that could be learned from your approach?
Okay, I can start. So obviously it's a multidisciplinary work. So I think the terminology was something that we had to deal with in the beginning because Neil, who is the most technical among us, had all these approaches that maybe for us were not known at the time. So this atlas-based segmentation was something still novel when we started. I think here, and also we noticed with the other members of this work that maybe the credibility of the technical approaches or new approaches has to be a bit more justified. And then, for example, something that is considered already established, like the mock-up and artificial aging, that's already something that people in this cultural heritage fields know about and they trust more. But whenever technology, or let's say more recent technology, comes into place, I think we need to explain more and justify more. And then I think, again, one takeaway from me is that actually we need multimodal data. So that's the beauty of this work. And as you say, we have multiple results because we had all these data. So we had 3D acquisition, we had mockups, we had hyperspectral imaging, we had normal color digitization in pictures. So this is something that is very useful. So continue to digitize and try to combine all this data. So try not to use them only individually, but try to fuse them in a way. And then obviously there are always challenges. So I think in general in this task of prediction of aging and restoration of the past appearance of an artwork is in general the lack of ground truth. And this goes again back to credibility, where we have to continue to justify, or we have to have a lot of explanation why we did something, why we choose a method. Because when you don't have a ground truth, it's difficult to prove that what you did is actually perfect. Then if Neil wants to add something.
I think you summarized it very nicely, but only thing I can add regarding the ground truth is like what we were talking about, this eon-based approaches. So if it's a bit invasive, like you can have a single thread or something, and from that thread, you can measure the appearance. That would be more plausible. So for me, the most learning was like I was not from this cultural heritage background. I was more into technical side, and then got to know about the details. So, but we should also like understand what we do from both parties, and it's very interesting when we could combine this in a multimodal manner. And the multimodal also, I think it's quite interesting because a pixel in theory has a very less information than a word. So for like textual data can also be included somehow for color representation. Not in this scenario, maybe in some areas when we have, because a word has a lot of more information than a pixel. And hence we have this multispectral data. We have more pixels than a single pixel, which gives us more information. And so multimodality is the future, I think, for more better reconstruction.
Fully agree with that. Right, we are nearing the end of this session. So if there are no additional questions, I would leave the floor to the organizers in case there are any technical information about the next webinars. Otherwise, we can just close the session with thanks to everyone else. So I'll just wait online for a few seconds in case there is any additional information coming through from Ivana and Cristiana. Otherwise, I just wanted to thank the speakers today for their very interesting, very information-dense presentations. And I really look forward to seeing everything all nicely wrapped up and packaged in time for the end of the project. See how
Thank you, Lucia. Well, thank you for being our contact person in the museum, because without you, we wouldn't have had these case studies. So coming back to the previous question, museums should give access to their collections so that they can be studied. That's very important.
Yep, and I fight that battle every day. So yeah.
And thank you for the moderation of the day.
Thank you. So I think this is it. And thank you very much for participating, and see you at the next one. Check our social media and check the website, and you'll find more information about what is coming up next there. Thank you. Bye.